Module 9.2, Polar Form, De Morvis Theorem, and Parametric Equations. 8.5 and 8 through 8.8 in your book. Polar equations and parametric equations are often used to restate trig problems, to study them in a different way or more easily study them. We're going to see how to convert between complex numbers and rectangular form numbers to polar form numbers. Then we'll study some properties of complex numbers in polar form. And then finally we're going to look at the graph of parametric equations. You should be able to easily go between rectangular and polar form and vice versa. De Morvis theorem is very useful, so you should definitely know that one. And you should be comfortable using a graphing calculator. And always make sure that you're in the right mode. That's going to be a big concern in this section. Make sure you're in the right mode. So let's talk about the complex plane real quick. We know about imaginary numbers or complex numbers like a plus bi, where we have a real part and we have an imaginary part. So on the coordinate axis, instead of saying x and y, we're going to say x and iy, or just to say that that's the imaginary part there. So for example, if we wanted to graph 3 plus 4i, that would mean that 1, 2, 3 on the real part and 1, 2, 3, 4 on the imaginary part. We're going to say that distance is still r, and this angle is still theta, just like before. And we'll study complex numbers just like we did any other triangle. So we're going to have that, just like before, x, the x coordinate, if we're trying to find that value, is r cosine theta. Y will be equal to r sine theta. R, just like before, is equal to x squared plus y squared square roots. And tangent theta will be y over x, just like before. So because of this, any complex number x plus iy, in other words, r cosine theta plus r sine theta I, because you can factor out the r there, is equal to r cosine theta plus I sine theta. Any complex number can be written like that. And that's what we call polar form or trig form. Another name for r is the modulus, and another name for theta is the argument. And instead of writing r cosine I sine theta, sometimes we write r cosine I sine theta, just to mean that theta goes into cosine and theta goes into sine. And there's a plus I sine there. Just a shorthand way of writing that, so we don't have to write it the same way over and over and over. So let's try to figure out how to write 2 cosine 300 plus I sine of 300 in a rectangular form. In other words, can we find the x and y value? Well, we know that x is equal to 2 cosine of 300. That's our definition of x. Right. Remember that 300 is not all the way around, but almost all the way around. So we're in quadrant 4. And this reference angle is what? 300 plus 60 would give you 360. So really this is 2 cosine of 60, and it's still positive. X is equal to 2 cosine of 60 is 1/2. So x is equal to 1. Likewise, it says plus I times 2 sine of 300, or plus I of y. Well, what is 2 sine of 300? Again, that's the same thing as 2 sine of 60. Sine of 60 is square root of 3 over 2. So this is just equal to square root of 3. So in rectangular form, this is just 1 comma square root of 3, or 1 plus I square root of 3, since we're using the complex plane. There's a couple ways we can do this on the calculator, so let's look at that real quick. We're working with degrees, so we're going to leave it in degrees, and we're going to go to polar form down here. Second, quit. Now, we could just type in 2 cosine of 300, actually. And that would give us the x value, which is 1, 2 cosine of 300. And we could type in 2 sine of 300, which would give us the y value, negative 1.73. Oh, and this is in quadrant 4, yeah, so that should have been negative square root of 3. So it's a good thing we checked it. It's in quadrant 4, which means the y is negative. Square root of 3 is negative 1.73205, so this is just another way of saying square root of 3. So you have to be careful there. Another thing you can do is you can go to the math option here. If you click on, or sorry, the angle option, second angle, there's an option there that says R. So we need the one that says P Rx. And what that's going to find is the x value if you have the polar coordinates. So the P means you have the polar coordinates and you want to find the x value in rectangular coordinates. And what you always have to type in is the polar coordinates, which is the radius and the angle. So 2 comma 300. And that would give you x is 1. Likewise, second angle. I have the polar coordinates. I want to find y. I'm going to type in the radius 2 and the angle 300. And it'll give me negative square root of 3, like it should. Let's do this next example here. Write negative square root of 3 plus I in trig form, in polar form. So second angle. I have the rectangular form, and I want to find the radius. So I can write it as something times cosine of an angle plus I sine of an angle. But first I need that radius to begin with. So R, because I have the rectangular coordinates, I'm going to type them in, negative second square root of 3, comma, and then the y value for the imaginary part, which is just 1 times I. So that gives me that the radius is 2. Second angle. Again, I have the rectangular form, and I want to find theta. So I'm going to type in negative square roots of 3, comma, 1, and I'll get 150 degrees to 150 degrees. So we have R is equal to 2 and theta is equal to 150. We have to make sure that makes sense. We have negative square roots of 3, that's negative x, it's over here somewhere, and positive 1, it's over here somewhere. That could possibly be 150 because it's not quite at 180 yet, so far it makes sense. So the polar form of this would be 2 cosine of 150 plus I sine of 150. If you wanted to do it the long way, you would need to find R. R is the square root of 3 squared plus 1 squared. Square root of 3 squared is 3 plus 1 squared is 1. Square root of 4 is 2. And then you would need to do tan inverse of y over x, or 1 over negative square root of 3. And that would give you 150. But you have to be careful that it does give you 150. It might give you something like 30, and then you have to make sure that you're in the right angle. So if it gives you 30, you have to make sure that you go negative square root of 3, 1, and then you shift over. There are some things we can do in the graphing calculator. but it's important to always sketch the complex number, the correct quadrant. This is what we always need to do, just to make sure we're getting angles that make sense. Multiplying complex numbers in polar form. Whenever we're multiplying complex numbers, so r then cis something else, then we just multiply the radiuses, r1 times r2, and leave it in the very front. And what we do with the angles is we end up adding them. Theta 1 on the left here gets added to theta 2 on the right. So we have cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. It's very similar for division. If we're dividing two complex numbers, we divide the radiuses, and then now we just subtract the angles. So let's look at an example. If we wanted to find this product, we do 2 times 3, which is 6. And then cosine, since we're multiplying, we're finding a product, we do 30 plus 45, which is 75, plus I sine of 75. And that's it, and then we simplify that. De Moivre's theorem. That says that if you have some complex number in polar form and you raise it to some exponent, it's the same thing as raising the radius to that exponent, r to the n, and then multiplying the angles by that exponent, saying n times theta. So raise the radius like you would normally, but multiply the angles by n. So for example, how can we write this complex number in rectangular form? In other words, we would have to do 1 plus I squared root of 3 times 1 plus I squared root of 3 8 times, plus 1 plus I squared root of 3 8 times. But that would take forever. So instead of doing that, we're going to write this in polar form first. So it says write in rectangular form, but we're going to go to polar form first, and then we're going to go back to rectangular form. So let's look at what this is equal to in polar form. Second angle. We want to find r, and we have the rectangular coordinates. We have 1 comma square root of 3. It gives us 2. Second angle. And we want to find theta now. We have the rectangular coordinates. 1 comma square roots of 3 square roots 3. $60. So this might as well say 2 cosine 60 plus I sine 60. 2 cosine 60 plus I sine 60 to the 8th power. Now we use De Moivre's theorem to say this is 2 to the 8th cosine of 8 times 60 plus I sine of 8 times 60. And now we just simplify. Right? Just find what 2 to the 8th is and multiply times cosine of 8 times 60. Then find what 2 to the 8th is and multiply it times sine of 8 times 60. And you're done. That's it. Once you do that multiplication, you're done. The nth root. A plus bi is a complex number that is an nth root of x plus yi if a plus bi raised to the nth power is equal to x plus iy. In other words, to find the nth root means to find a number that when you raise it to the nth power, you get that number back. The nth root theorem. The nth roots of some polar form number are given by taking the nth root of the radius and then finding cosine of alpha where alpha and sine of alpha where alpha is equal to the angle theta that you started with divided by n plus different multiples of 360 over n. So let's try an example. The fourth roots of negative 8 plus 8i square roots of 3. Well, let's write it in complex form. We have to find r, which is the square root of 8 squared, which is 64, plus 8 square roots of 3 squared, so 64 times 3. Let me write the step before that, just in case. 8 squared plus 8 square roots of 3 squared, which is, here's 64 plus 3 more 64s, which is 4 times 64. The square root of 4 is 2, and the square root of 64 is 8, so this is 16. So 16 CIS, instead of writing cosine sine, I'm going to write CIS, and this is tangent of theta is equal to 8 square roots of 3 over negative 8, or negative square roots of 3. Remember that theta was equal to pi over 3 would have given you positive square roots of 3. So pi over 3 here would have given you positive square roots of 3, because tangent is positive there. But negative pi over 3 would give you negative square roots of 3. Okay. But we have to be in the right quadrant. This is negative 8, so negative 8 would be 1, 2, 3, 4, 5, 6, 7, 8. Positive 8 square roots of 3 would be up here somewhere. So we have to be in quadrant 2 actually. So instead of pi over 3 or negative pi over 3, we need pi over 3 plus 2 pi over 3 plus another pi over 3, which would give you 2 pi over 3. Let's try it on the calculator real quick. Alright, second angle. Which one do we need to use here? What do we want to find? We want to find r, little r, so we're going to put in negative 8 comma 8 square roots of 3 gives us 16, which we found already. Second angle. Now we want to find theta. Negative 8 comma 8 square roots of 3, which gives us 120 degrees. Remember, in radians, 120 degrees is 2 pi over 3. And use degrees anyways, 120 degrees. Okay. So the fourth roots of that is just 16 raised to the 1/4. Right, and then CIS of alpha, where alpha is going to be different numbers. Alpha is going to be first 120 divided by 4 plus 360 over 4 times 0, right? So first, no, you don't add anything to it. Then the next one is going to be 120 over 4 plus 360 over 4 times 1. The next one is 120 over 4 plus 360 over 4 times 2. Then the last one is 120 over 4 plus 360 over 4 times 3. Those are going to be the four roots right there. What's the fourth root of 16? The fourth root of 16 is 2. This should be CIS of 120 over 4. 120 goes into 4 goes into 120 30 times. The next one is 2 CIS This is still 30 plus 360 divided by 4 is 90. So 90 plus 30 is 120. 2 CIS. What's the next one? $120 divided by 4 is still 30. 360 divided by 4 is 90 times 2 is 180. So 180 plus 30 is 210. What's the next one? 120 over 4 is 30. 300 divided by 4 is 90 times 3 is 270. 270 times 30 is 300. So 2 CIS 300. Those are your 4 roots. Right, and you still have to find those values, right? You can still plug those into the calculator and figure out what those numbers come out to be. Right? One should be 2 cosine of 30 plus 2 sine of 30 times I. There's an I in front of it. The third one would be 2 cosine of 210 plus I 2 sine of 310, etc. Find the real and complex solutions to x squared plus 4 is equal to 0. In other words, find the solutions to x squared is equal to negative 4. In other words, find the second root. Find the 2 roots of negative 4. Remember, we can't find real numbers there. These are complex solutions. There's nothing you can square to give you, there's nothing here that you can square to give you negative 4. That's real. Right? We have to use complex solutions. So again, we're going to convert this to polar form. X is equal to, instead of negative 4, what can we use? R is square root of negative 4 squared plus, what's the imaginary part there? There's no imaginary part, so it's just 0 squared. 16 4. Okay, and how do we find theta? Well, theta is equal to the imaginary part, which is 0, over the real part, 4. Sorry, tangent of theta is equal to the imaginary part over the real part, which is 0. So theta, when is tangent theta is equal to 0? When sine is equal to 0, in other words at 0 or at 180 degrees, but remember, since negative 4 means that we're on 1, 2, 3, 4 on the x-axis, that's in the second quadrant, that means we have to go with 180. So this might as well say x is equal to r, which is 4 CIS 180 raised to the 1/2. So that's what we need to find the second root of. But this isn't that difficult to do. The square root of 4 is 2 CIS 180 divided by 2. Using the Moivre's rule now, you multiply times 1/2. Right, this is 1/2 times 180, which would give you 90 plus 0, right, for the first one. Then the next answer is 2 CIS 90 plus 360 divided by 2 again times 1. 360 goes into 2 180 times, or 2 goes into 360 180 times. So that would be 2 CIS 90 plus 180 is 270. So the two roots are 2 cosine of 90 plus I 2 sine 90, which is, cosine 90 is what? 0. I 2 sine 90. Sine 90 is what? 1. So this is just 2i. That's one root. This is 0. And the other root is 2 cosine of 270 plus 2i sine of 270. Cosine of 270 is what? 0 again. 2i sine of 270 is negative 1. So this is negative 2i. And those are your two roots. In other words, those are the two numbers that you can plug in, square them, and you'll get negative 4. 2i squared is 4i squared, which, remember that I squared was negative 1. So this is negative 4. Same thing for negative 2i. If you plug that into x and square it, you'll get negative 4. So the complex solutions, it's only complex solutions, is 2i and negative 2i. That was a lot of work for that though. So make sure you practice this and ask questions if you have questions. Okay, polar coordinates. Polar equations and polar coordinates. Just like we said before, if we have some coordinate and instead of labeling it by x, y, we want to label it by r and theta, we can do that. And the same rules are going to apply. R squared is still equal to x squared plus y squared. Tangent theta is still equal to y over x. X is equal to r cosine theta, etc. So now we're going to go the other way around. Find the rectangular coordinates if we have the polar coordinates 2 and 30 degrees. We've already done this, so let's go ahead and try it again. What are we trying to find? The rectangular coordinates. So we want to find x first, given the polar coordinates. And so given 2, 30. X is 1.73. Do you remember what that was? That was the square root of 3. Yeah. So you have to be careful. So x is square root of 3. Let's look at the y value now. Second angle. We want to find the y value when the polar coordinates are 2, 30. The y value is 1. We have square root of 3, 1. So when we have something in polar coordinates with a radius of 2 and a degree of 30 degrees, we could easily find the x and y coordinates, square root of 3 and 1. Alright. We can also convert equations into polar equations. So for example, this is a rectangular equation. We can convert it to a polar equation. If we just substitute what we know about x. X is equal to r cosine theta. Y is equal to r sine theta. So let's just substitute that in there. R cosine theta squared plus r sine theta squared is equal to 9. We square both r's and both cosines and sine thetas. So it gives us r squared cosine theta squared plus r squared sine theta squared is equal to 9. If we factor out the r squared, we get r squared is equal to cosine theta squared plus sine theta squared equals 9. And remember, this right here is equal to 1. That was an identity. So this says r squared times 1 is equal to 9. So that's our polar equation. It's a lot simpler than writing x squared plus y squared is equal to 9. It just says r squared is equal to 9. In other words, this tells you that this equation is just, in polar coordinates, the thing with radius squared is equal to 9. In other words, if the radius is equal to 3, positive 3 here, 3, positive 3, positive 3, that length, or negative 3, negative 3, negative 3 down here, 3 squared is equal to 9. That's just a circle with radius 3. That's what this is. It's a circle with radius 3. Just a different way of describing it. How about for the line y is equal to 2x plus 2? Well, same thing. R sine theta is equal to 2 r cosine theta plus 2. And what can we do? We can group the r's and the thetas together if we wanted to. So let's subtract r sine theta. Let's subtract this 2r cosine theta minus 2r cosine theta is equal to 2, and leave this 2 alone on this side. Then we're going to factor out the r, just like we did before. Just take out an r from both of these and put it out in front. Then we're going to divide, since this is times, we're going to divide by sine theta minus 2 cosine theta. And that's going to give us that r is equal to 2 sine theta minus 2 cosine theta. And that's another way of writing this line. Y is equal to 2x plus 2. We can graph that on the calculator, so let's try that real quick. So we are in polar mode. Let's see, we went down here to polar mode. We're going to go second, quit. We're going to go to y equals. Now notice that this doesn't say y1 is equal to anything. It says r1, which is why we wrote it in this form. So we can write 2 divided by, 2 divided by, let's make sure all the stat plot is off. It's just, I left it on in this calculator. Off. Okay. 2 divided by parentheses, just to make sure we're dividing by all of this. Sine of, notice now if we hit x here, it's going to use theta. See? Minus 2 cosine theta. Close that parentheses and then close the parentheses so everything stays in the denominator. Then I'm going to hit graph. Let's go to zoom. Just get a standard view of this. Zoom standard. Zoom 6. That graphs a straight line. It graphs a straight line 2x plus 2. Just as if we would have typed in 2x plus 2. Find the rectangular coordinates of a polar equation. Likewise here, r, because r is equal to square root of x squared plus y squared. Right. We could possibly use that here. Let's see if we could do something else. If we multiply this over, we get 1r plus r sine theta is equal to 4. Then what could we do? R sine theta, we know that this is equal to y. R sine theta is equal to y. So this is r plus y is equal to 4. But we still need to get rid of this r somehow. So instead of writing r, we can just write the square root of x squared plus y squared plus y is equal to 4. We can subtract the y over. X squared plus y squared is equal to 4 minus y. And then if we square roots, and then if we wanted to, we can just square both sides. If we square both sides, the square root goes away and we're left with x squared plus y squared is equal to 4 minus y quantity squared. And we can keep on going and simplifying this thing if we wanted to. We can keep simplifying that by multiplying out the 4 minus y squared, which is equal to 4 minus y times 4 minus y, which is equal to 16 minus 8y plus y squared. So we know that x squared plus y squared is equal to 16 minus 8y plus y squared. The y squares cancel. I'm left with x squared minus 16 is equal to negative 8y, or x squared minus 16 over 8, negative 8, sorry, is equal to y. And now we have an equation y equals something in terms of x instead of r something in terms of theta. That was a lot of steps, but the whole point is that you can get rid of r and theta just by using substitutions. Here we used r sine theta is equal to y, and here we used that r is equal to x squared plus y squared. So we use two definitions. This is the important part right here, and that's the next important part. The rest is just algebra. Alright, parametric equations. This is a different type of equation. A plane curve is a set of points x comma y described by two other functions. So now instead of just saying x and y, right, x comma y, or 2 comma 3, etc., we have functions describing x, right, that when you plug in t goes in and it gives you an x and a y. These are called parametric equations. And usually t represents time. That's why we use t, just to represent time. So for example, the easiest one is, what if time is equal to x is equal to t, and the time is just bigger than 0, 1 second, 2 seconds, etc., 1.3 seconds. Well, we just graph this as we usually do. When t is equal to 0, then we get y is equal to 2 times 0 plus 3. Y is equal to 3. So we get, on the x and y axis, we get 0, 3. When t is equal to 1, we get y is equal to 2 times 1 plus 3, which is equal to 5. So on the x-axis, so we get x is equal to 0 also, and x is equal to 1 also. So we get 1, 5, etc., and we're going to get a straight line. So we're just using t to describe x and y. That's the only difference. So how can we find the rectangular form for x is equal to t squared, y is equal to 2t plus 3? In other words, how can we write that not using t's? Well, we can solve for t in one of these equations. So here, for example, I can get rid of the t's by solving for t. This is y minus 3 is equal to 2t, which says that y minus 3 over 2 is equal to t. And now, because I know that t is equal to y minus 3 over 2, I can just plug that in there. And I'll get x is equal to y minus 3 over 2 squared. And now I have a function, an equation with no t's in it, just x and y. Right? And usually x is equal to t is pretty easy to use. You can use whatever you want to. For example, here, if we wanted to describe y is equal to this curve using some sort of parameterization, I can just say, just to make it easy for me, I can say t is equal to x minus 2. Or in other words, x is equal to t plus 2. So when time starts at 0, and so on, t is bigger than 0, I can always find an x. T is equal to 1 would give me that x is equal to 3. T is equal to 2 would give me x is equal to 4. But that also tells me that I can replace x minus 2 with t. So this might as well read t squared plus 1. and that's my parameterization. X is equal to t plus 2, and y is equal to t squared plus 1. And now all I need to know is that t is bigger than 0. But I can choose something else. I could also say x is equal to t if I wanted to. Whoops, x is equal to t. Then my parameterization is x is equal to t, y is equal to t minus 2 squared plus 1. And it's still the same thing, it just looks different. So practice this one on your own. A common parameterization of an object that is thrown in the air with a velocity v, so it's thrown in the air with some velocity at an angle theta, is x is equal, that x is given by the velocity times cosine of the angle times the time, and then y, so the x is how long it's traveled, how far it's traveled in the horizontal direction, and y, how vertical it's traveled, is given by v sine of theta. In other words, the velocity times sine of theta times the time minus 16 t squared plus h, where h is the height of the object. In other words, the height at which it was thrown. So assume two golf balls are thrown at an angle of 30 and 45 degrees with a velocity of 132 feet per second. And let's say they were thrown, because I didn't say here, with a height of 0. They started at 0. In other words, maybe they were hit by a golf club. There's one ball and there's the other. So how can we tell which ball travels the greatest distance? In other words, the x direction. Well, we just have to use the formula v cosine of theta times t. We don't even have to worry about how high it was thrown from. So this thing doesn't matter. That's why we didn't say where it started from, because how far it travels horizontally has nothing to do with how high it started. So we have two equations. X is equal to the initial velocity of 132 feet per second times cosine of 30 times t, and x is equal to 132 cosine of 45 times t. And what does that equal? Cosine of 30 is what? Square root of 3 over 2. So this is 132 times square root of 3 over 2 times t, or half of 132 is 15, 65, 61, 61 square roots of 3 times t. Cosine of 45 is square root of 2 over 2. So this is 132 square root of 2 over 2 times t. Same thing, 61 square roots of 2 times t. So which one travels the furthest? The one that was shot at an angle of 30 degrees. Because square root of 3 is bigger than square root of 2. Okay, you are now ready to start homework section 9.2. And then we have one more after this, so you're almost done. Good job.